Welcome to Advent Chem Bio, where we seek advent of new chemistries every day. Today we are discussing about short peptides and amino acid derivatives, especially as working standards. Whether you are a student, a researcher, or just curious about chemistry, this is the video for you. Let us get started. First, let us discuss briefly what peptides are. Simply put, peptides are building blocks of proteins. They are basically a short string of 2 to 50 amino acids joined together through amide linkages and formed by successive condensation reactions. For example, a dipeptide contains 2 amino acids, tripeptide contains 3, tetra contains 4, deca contains 10, and an oligopeptide contains 2 to 20 amino acids. And a polypeptide is a single linear chain of amino acids containing as many as 50 or more. And a protein is a combination of 2 or more polypeptides. One example is insulin. Insulin is a protein which is composed of 2 polypeptide units. The chain A contains 21 amino acids and chain B contains 30 amino acids linked together by sulfur atoms. Peptides are essential for many physiological and biological functions, including enzyme activity, hormone production, and immune responses. Because of their importance, it is very, very crucial to have accurate working standards and substandards during research and application, as well as during the validation exercises of peptide drugs during the different stages of the synthesis. Working standards refer to pure and characterized products used as benchmarks in experiments and quality control. These standards ensure that the analytical results are accurate, reliable, and consistent across different laboratories and applications. As peptides are formed from 2 or more amino acids, generation of impurities at each stage of formation remains a distinct possibility. So before going to the next stage of production of the peptide chain, it is essential that product is purified and analyzed for the presence of the possible impurities. They can be like number 1, if the KSM is a L isomer, the impurity can be a D isomer. For example, if FMOC L-tyrosine is a reactant or a KSM, then FMOC D isomer is an impurity in that. It can be a modification of the KSM. For example, FMOC L-alanine. It can have actually a beta-alanine as an impurity. And another is orthogonal protecting groups. Suppose say both BOC and FMOC are present in one of the KSM like L-lysine. Then single BOC derivative or FMOC derivative of L-lysine can be an impurity. To create working standards of these impurities, the respective target molecule after its synthesis must undergo rigorous characterization and purification process to get optimum purity. Techniques like high-performance liquid chromatography, mass spectrometry, NMR, be it proton NMR or carbon-13 NMR, IR, and specific optical rotation are used to confirm its purity and identity. Most of these subpeptides or amino acid derivatives or related impurities, they are not available as primary standards with global brands. Some of them, they are not even having their cache numbers registered. In that scenario, they are serviced as working reference standards with purity and potency with all corroborative data to customers who work on peptide drugs. As I told earlier, these working standards help in the validation exercises at each step of peptide chain synthesis and also during development and manufacturing of peptide drugs. Any deviation in the standard at any step can lead to inaccurate results and harmful consequences. Maintaining these working standards involve monitoring and re-evaluation. Best practices include proper storage conditions, documentation, and re-validation. This ensures that the working standards remain stable and effective for their intended use. Advent Chem Bio has been able to develop a series of short peptides and amino acid derivatives as working standards in milligram to gram scale. Some of them include EPMOC amino acids, both D and L isomers, BOC amino acids, both D and L isomers, CBZ amino acids, dipeptides, tripeptides, tetrapeptides, and substituted amino acids like not-butyl derivative, trityl derivative, MMT derivative, alloc derivative, as well as esters and alcohols, etc. Hundreds of such amino acids are available in our range, and some of these working standards are not even having their CAS numbers available. In summary, working standards of short peptides and amino acid derivatives are backbone of accurate and reliable peptide research and application. They ensure reliability, consistency, and safety in the synthesis of peptide drugs at different stages of development and manufacturing. Thank you all for watching. I hope this video has provided you with clear understanding of working standards of short peptides and amino acid derivatives. If you found this video useful, please like, share, and subscribe for more informative contents. Until next time, stay tuned and stay curious about the wonderful world of chemistry.